So, for example, if I create a list, Python, Python, a list, so how to sort this list in Python? There are two ways. Huh? So, one way is to use method sort. And after that, if I print a list, it will be sorted. So the first question, is it in place operation or not? So in place operation, I remind, it changes your object. So it doesn't create a new object. It changes your object. That's why it's called in place. So from this example, what do you think? Is it sort is in place or not? Huh? In place, because I print my original object, original list, and it's sorted. So if you don't want to sort the original list, there is another way to do this. So again, I will create a list, and to make it easier, I will just use random numbers. And list comprehension. And for example, numbers from 0 to 100. And for example, 10 values for something in range. So it creates a list of random numbers, and we can use sorted function, and this function will sort our list. You can assign. So this function actually has return statement, so it returns a sorted list. So you can assign this value to a new variable. But if I print my list, original list, it wasn't changed. So this operation is not in place operation. Okay, so the second question, this was the first question, how to sort in Python. Second question, which sorting algorithms are typically used for sorting? Huh? So last time we talked about insertion sort. Maybe you remember also bubble sort, when we just go through entire list and choose the smallest one. Then we go through the remain n-1 values and choose the smallest. So, and today we'll talk about merge sort and quick sort. So do you know which algorithm is used under the hood in Python? Yes?
Merge sort.
No, quick sort. No, quick sort is used. Yep.
I'm reading like their variant of merge sort they use for top ordering.
Yes.
They specify it's a variant of merge sort.
So Does it say that Python uses merge sort?
Yeah, 3.11 on,
Oh,
3.10, 3.11.
I believe it's used, typically it's used quicksort. I believe it also depends on the length of the data. So, okay. At least we will learn both algorithms today. So the first algorithm, merge sort, from the name, from its name, it follows that we should merge something. But before merging, we should split. So the algorithm is as follows. We split our list in just in the middle. And then we split every smaller list into halves. And what about now? When we reached the level when each list contains only one element, are these lists sorted or not? I mean, one element lists. They're sorted. So we can start from here merging, and we will merge two sorted lists. So the first step, we will merge lists 8 and 3. 3 is smaller, so we should swap them. This is the first merge operation. In the second merge operation, we don't need to swap them. Now we have two element lists, and they are sorted. We should merge now two sorted lists. And now I will explain how the merge operation actually works. We look at the first elements and choose the smallest one. So here we will choose 3. And now we will have one list of one element and one list of two elements. Now we compare again first elements of the remaining lists, and we see that 5 is smaller. So we will take 5 in our result. And finally, we compare the remaining lists. So 6 is smaller, we will take 6, and on the right, we will have empty lists. After one of the lists is empty, the remaining list, it's sorted. We just concatenate entire remaining list to the end because it's sorted. So now we will go for another example. First, we split into halves until we reach one element list. And then we begin merging. So the first merge, now the second merge. We compare the first elements. If it's 2 is smaller, so we take 2 first to the result. Then we compare 6 and 4. 4 is smaller. We remove 4 and append to our result, and here we will have empty list. So the remaining list we just concatenate to the result because it's already sorted and it has numbers greater than previous numbers. Okay, so now let's code this, and then we go to quicksort. Oh, here is more visualization how the merging process goes. So compare first elements. 1 is smaller. Then we compare. So we kind of remove this element from our list. Compare again first elements. 2 is smaller. We take 2. We kind of remove this element. And then compare 4 and 6. 4 was smaller, so we removed 4. Now we again compare first elements and so on. So let's write the function, define merge sort. Oh, so I think as I think they pronounce correctly, or what's your name? I think no.
Asta.
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 Asta. Did you check the which in which cases merge sort is you or you didn't? Yeah, could you check this? So you will tell us which actually a certain algorithm is used under the hood. If I remember, it's a mixture, so it depends on the input length. So a merge sort, the input will be a list. The base case will be, we will check if a list is empty or it contains one element. In this case, it's sorted. So if length of list is smaller than 1 or equal, return a list. Otherwise, we should split list into 2 halves. And in practice, we don't split by middle index, but we split using even indices and odd indices. So, for example, let's for example, we have this list, and the first half, in the first half, we will take elements with indices 0, 2, so all even indices. And it will be our left list. And our right list will contain the numbers with odd indices. So how to get the numbers with even indices? Yeah.
Number 5, 2, 0.
This is one option, but there is an easier way using slices. So how to?
How does that?
So how can we do this using slices?
Using a
Step
of 2.
Step 2. Yeah. So and this is how we actually will split. We will just use a slice, step 2, and it will return the every second element. So here, if the length of list is greater than 1, we can split it into halves. Okay, so let's create left and right lists. Left and right. So left list will be a list with even indices. Right list will be the list with odd indices. So it will the first index will be 1 and step will be 2. After splitting, we should we're doing next. we continue splitting recursively, and until we reach the length of list 1. After we reach the length 1, we will merge them. So we will write the merge function later. For now, I will just use this. So return merge. So this function we will write just in a few moments. And here we continue splitting. So we apply merge sort to our left and right halves. Okay. And fine, now we will write function merge. Of 2 halves. How how we will merge? So we should look at the first element of each list. So let's create an empty list for the result of the merging. And we will initialize indices for both lists, index 1 and index 2. And then we will do a while loop while index is smaller than the length of our array, it means that we didn't go for the entire list. So while index 1 is smaller than length of the first list and index 2 is smaller than length of the second list, we will compare the first elements. So if left of index 1 is smaller, then we will append this element in our result. Otherwise, we will append the first element of the second list to our result. Is smaller than the first element of the right. Result, append this smaller element, index 1, and increase index by 1. By the way, they can be equal, so I will write if it's smaller or equal, else means that the first element of the second list is smaller. So I will append the second element. Result, append the first element of the second list and increase the index of the second list, like the pointer. Finally, we will reach a point when the length, when index is equal to the length of one of the lists. It means that we will go for the entire list. At this point, we will just concatenate the remaining list. to our result. So let's, after while loop, let's check if index 1 is smaller than length of our left list. So what does it mean that index 1 is smaller than the length of the first list? Does it mean that the first list is empty or the second list is empty? If index 1 is smaller than the length of the first list, it means that we didn't reach the end of the first list. So the first list is not empty. But because the while loop was actually stopped, it means that the second list is empty. So we will append the list, the remaining list, which is the first one, which is not empty. So result, append the remaining list left from index 1. Otherwise, the second list is not empty. We will append this, concatenate the second list. That's it. The merge function is ready. And return result. Okay, now let's test our function. Because Python is interpreter, I can import in the middle of my code. For the best practice, you should import all the packages in the beginning of your code, but here, for me, it's easy, just import here the random from random. To test, I want to create an array with random numbers. From random import randint. Create a list for my list. Randint. For so if if the variable of iteration is not important, we use underscore typically for. You can write also for I in range or for underscore in range. Let's say 10 and print original list and print the sorted list. Okay, let's test. Okay, it looks like I even didn't make a typo. So the input list and the sorted list looks correct. So the second algorithm is quicksort. But before we go into this algorithm, oh, and by the way, the code is on the course page. It's a little bit different, but if you need to look at the code, you can look on the course page. So where is my pointer? Oh my gosh. I don't see the pointer. Where is this? Oh, here it is. Okay. So, in this merge sort, we split our list into two halves. Do you remember what is the name for this group of algorithms when we apply this algorithm to the half of the data? What is the name for this class of algorithms? Like binary search, you remember we we were using the middle index and compared our element with middle index. Then we continued our search or in the smaller part or in the larger part, depending on the if our element is greater or smaller of this middle element. So what is the name for, yes, the remember?
Divide and conquer.
Divide and conquer. Yes, so this algorithm, merge sort, is one of the divide and conquer algorithms. The next algorithm, which is quick sort, is also from this family of divide and conquer, but we will now split our array into three parts, not into two parts, but into three parts, and apply this algorithm to these parts. So first we choose one element, and typically we use the first one. So it's called pivot element. And then we split our numbers into three groups. Numbers smaller than this element, numbers equal to this element, and numbers greater than this element. So we create three lists. Then we apply our sorting algorithm to each part. Do we need to apply sorting algorithm to the middle list? No, it's already sorted. So we apply sorting algorithm to these halves. After that, we will get sorted lists, and then we'll just concatenate all three lists. So this is the idea of quick sort. And now Aidan will show you the Vim editor and also write the code for this quick sort algorithm, okay? Oh yeah. But please increase your font when you will demonstrate. So is it like this? I will try to record the screen. I don't know if it... Oh, yes, it works. Or you should switch to... Yeah, now it's off. And yeah, could you maybe increase? Is it okay now? The font size. Okay. So what maybe so you're working in the command line, yeah?
Yes, yes.
Yeah, so maybe you can just explain what are the commands are you using?
touch just creates a file, so
Touch creates a file, okay.
yes, you can see QSort is a file now. And then NV is,
Sorry.
NVim is just a variant.
Oh, and V is, there's a shortcut?
Yeah, it's an alias, it means the same
Alias
thing.
for Vim, okay.
Um,
Oh, and Vim also an alias?
and NVim is a variant of Vim.
Ah.
It's called NeoVim, it's what I use. But
What's the difference?
it uses Lua instead of InScript to configure stuff.
Explain what
But-
that means.
But it's built in
It's
in
the,
Linux, or you need to set up it?
you need to download it
Oh,
separately, but it's like, it looks the same. pretty much.
maybe you can show just Vim, so,
Sure.
I mean,
Then QSort.
Oh.
So this is an active file and
so this is the editor, how it looks like before Windows.
Yeah. So Vim was released in 1991. This is what they use. Let me just switch some stuff so it looks better quickly. Yeah, okay, cool. So then Vim has like different modes. So right now, if I try to type, nothing happens. I have to enter insert mode with like A, and then I can type whatever I want.
So you just press insert?
I press I works.
I.
Yeah.
So there are shortcuts.
Yeah,
I can hold.
so what key sort takes a list. By list.
Okay, and now I don't,
Because
you
you
just
just
write the file,
Yeah,
You don't, he doesn't use his.
Oh, by the way, I didn't talk about this. It uses the type. So if you want to indicate the expected type of your variable, like list, you use colon and expected type.
so Q sort is gonna call itself if it's in empty list.
Yeah. So again, base case.
It's Q sorted. So it's, if a lower, all the values that are lower.
So then we should partition our list. Yeah, you can write left same right, and partition function will be defined later.
And
Enter
then,
top.
Sort of that is that.
Of left, yes, plus same, the same, we don't need to sort. And sorted right part. Okay, so this is the function for quick sort. The only thing that remains is to write the partition function. And so in your code, in this on the course page, the partition function has two arguments, list and pivot. But because pivot is always the first element, it's redundant, so we will use just lists. Okay. Let's create pivot. Pivot equals list of 0, the first element. And then we'll just go through the entire list. You can, oh, sorry. First, create 3 empty lists, Adam. 3 empty lists, left, same, and right. And then we will go through the entire list and populate this list. And the 4 element in list or something like that. Yes. And compare, if element is smaller than pivot, we will append this to the smaller. Oh, okay. You're using names left, same, right is okay. Usually we use the names smaller, same, and greater, but it's fine. Use left, same, right is fine. Oops. Elif, if it's greater than we append to the right. And else, the only option remains, they are equal. And return the three elements. No, 3 times or.
Sorry.
And maybe you return without those brackets. So in Python, if you return more than 2 elements, it returns the tuple. So it's a little bit redundant to write the, I mean, you can write in parentheses, but just return the 3 elements. Okay, and that's tested. So you can also create a random list and apply. Oh, yeah. So but did you check?
If it's greater, we use the same for power shape, which is like a regular first.
Yeah, continue. That was the other students. I am an agent. That I will that's
Yeah, it's gonna be.
okay, so
And line print precursor.
so how oh it I believe you should take the in brackets this random file. So it's called list comprehension. I don't think in square but like this. Yeah, yes. So now the file is ready. Could you learn how to save this file and how to run it?
Yeah, so to save it, it's just colon and W. To run it, you can run it from within the.
Oh, that will be for right.
Yeah.
That will be from right.
Yeah, colon W. Right.
You really died on the way down.
And now we are, or now we should go out. Sorry, should we close here or exit?
You can do either. If we want to run it within Vim, it's just colon, exclamation mark, and then whatever you command.
Oh, so you can, I didn't know this, so you can just execute your file from Vim using these exclamation style. Oh, it worked.
Yeah.
Great. Thank you. So yeah, I don't know why I thought that Vim is very complicated and I usually use Nano, but it doesn't look very complicated. Maybe you just need to remember the shortcuts, like all these commands.
Tutor is the standard way to learn Vim. It shows you all the shortcuts.
What was it?
What was the command?
What is? Mine doesn't work either. Actually.
Vim tutor.
Mine says maximum.
You have a-
Oh.
How does yours work?
Vim tutor.
Where's my
Oh.
face cam?
That's from that other list that you made.
Well, sometimes
Where's your
when you
base
go to the server, if you
base
want to
name?
open file on the server,
I have that too.
you can, without downloading this file. So then you will need to use the terminal editor. So Vim is one of these terminal editors.
What does it say?
The same code.
Maximum recursion methods.
Thank you, Aiden. So now we have information ready about which sorting algorithm is using in Python. So I think you can share with us this information.
Python uses binary sort, which is basically fixed order. It's length of list is less than 64. Otherwise, it uses
64 bits,
64 integers or 64 integers.
then 64 what?
Integers 64 bytes.
Oh, so it means 2 power 64.
Yeah, I'm pretty sure.
Yeah, so before this, if the list length is smaller than 2 power 64, it uses binary search, you said?
No, sorry. If it's less than 64 integers. If the size of 64 integers, 128 bytes.
Oh, I see. So
It's like their arbitrary size and let's just insert arbitrary size in Python. It's not based on memory, it's just based on 64 integers. It,
I see. So if the length of list is smaller than 64, so then binary search?
yeah,
Uh-huh.
not binary sort.
Oh, sorry, we're talking about sort. Binary
It's basically.
sort, but we didn't cover binary sort.
It's basically quick sort.
Oh, it's kind of quick sort. Okay, and if greater than merge.
It uses.
Variant. Okay, so it's good to know because now we will talk about complexity. And again, we're not doing the break, so feel free to go out if you but we will finish earlier. So let's talk about the time complexity, and it will maybe clarify why for smaller numbers, for smaller lengths, Python uses quicksort, and for larger values, it uses merge sort. So, if I can raise this whiteboard screen, so maybe I can just write here. So merge sort. Let's first talk about merge sort. Do you remember how many steps we should perform before we reach one element list? Last time we were talking about binary search, and we derived actually the formula when we reach one element list. No, so it's not n divided by 2. Yes, so for the first split, we have 2 lists. For the next level, we have twice more, so 2 power 2 lists. And when we stop when the length, the number of lists. What should be the number of lists when every list contains only one element? It will be the number of elements in the original list. So we stop when this number of lists is n. And when we solve this for k, then we will get that k is log base 2 of n. So this is the number of levels before splitting into one element lists. After we splitted the list into one element list, we begin merging. So what is the number of operation, or we say time complexity, for merging two sorted lists? So, for example, here we compare first elements and we create the first element of our result. Then we compare remaining lists, the first elements, and write into results. So in the end, we will get the list of the original length. So how many operations we will provide writing every time a number. It will be n, the number of elements. Well, maybe it will be 2 times n because we compare and then write, but it's still of the order of n. Does it make sense? So this is the number of levels, and we should multiply by the number of operations on each level by n. So this is the time complexity for merge sort, n times log base 2n. Now let's think about quicksort. And for quicksort, we will consider sorted, originally sorted list, or sorted but in the decreasing order. So if our list is sorted, we can start with this list, for example. So the pivot element will be 8. When we create the smaller, same, and greater lists, 8 will be in the same. But we don't have a greater list. So the greater list is empty list. Even though you can see here 2 lists, but in code, we have always 3 lists. So on the next step, we apply our quicksort to the smaller and greater. Greater is empty, so we apply to smaller. Oh, wait a second. Oh, but it's where it is sorted. Okay, there's a so this is the sorted list, but when we just split, we should get unsorted list from 7 to 1 and 8. But after we sort, I think that this is a little bit corrupted example. Okay, maybe we should look at this example. So the pivot element is the smallest now, and this is the remaining list. Now we don't have smaller list, we have greater list. So, and we continue. How many steps will we perform for sorted list? Every time we create the list, the same list from the next element. So how many steps will we take? The same as the number of elements, maybe n minus 1, but it will be of the order of n. So now the number of the levels will be n instead of log of n. And on each iteration, how many operations should we perform to create 3 lists? It's just copying elements. The same as the number of elements, because we copy each element. So for every step, we also perform n operations and oh, sorry, not always n. N for the first, n minus 1, n minus 2 for the second, n minus 3 for the third, because the size of list reduces, so it becomes smaller. So it means that here we perform n operations, then we perform n minus 1 operation, but then we perform n minus 2, and so on. So it's just the number of first n number, just not a number, the sum of the first n numbers. Do you remember what is the name for this sequence? I can write this backward. It will be 1 plus 2 plus 3 and so on. So what is the name for this sequence?
Triangular numbers.
No. Triangular numbers are the numbers that you can write like this, like 1 plus 2 plus 3, 1 plus 2. So what is the name for this sequence? Huh? There are two sequences that you, arithmetic, yes. This is arithmetic sequence. What is the sum of the arithmetic sequence? What is the sum of the first n numbers? If you answer this question, you will answer the question about time complexity for the quicksort, the worst case for quicksort.
Not n5 too.
So, did you hear about mathematician Gauss? Yes. So, yeah, you're almost right. So, yeah. So, the legend says that in school, Gauss had a problem to sum up first 100 numbers, and he just raised the hand and gave the answer immediately. So can you guess how he could calculate the sum of these first numbers? Yes.
First and suburbs and add them.
Yeah, you should notice that if you take the first and the last, the sum will be 100. If you take the second and upper last, the sum will be also 101.
Yeah. And then
And how many times should we sum up these numbers?
for half the.
Half? Yes. So the answer is 101 times 50. But the general formula, which will be what, 550, something like that. But the general formula is n. So the first plus the last, n plus 1, times the half of elements, n over 2. Which is about n squared. So the time complexity for completely sorted list for quicksort is actually n squared. What is the best time complexity? Can you think about the best case for quicksort? The hint is that when we split in 3 lists, actually only one list will exist.
All the same, right?
All the same, correct. So if we have a list just of the same numbers, when we split in three lists, we will get empty less, empty greater, and the same list is sorted. So what will be the time complexity in this case? Not a constant, because when we split, we perform an copy operation.
Oh, man.
N. It will be O of n. Yes. So, and you remember that in merge sort, any case, worst case, best case, average case, was n times log n. But in quick sort, in two cases, extreme cases, it's n squared. But we rarely sorted list. So, but in best case, the time complexity is small. It's just n without multiple. Now let's take a look at the illustration of different sorting algorithms. And actually it explains why for large lists, Python uses merge sort, because it has guaranteed smaller time complexity, but for smaller quick sort. So here is the illustration. Oh, sorry, I should raise the so it's hard to see here the names of algorithms. So it begins with oh, maybe I can find another illustration. Okay, no, maybe it's so so it's hard to see here the names of algorithms. So this is I believe this is quick sort, this is merge sort, and this is oh no, sorry. I don't know why. I will try to find another illustration. Oh, this is better. So it begins with random distribution of data. Okay. So the original distribution shows the height shows the number, like 90 or 1 and so on. So all the distributions are random and the same. So this should be quick sort. This is insertion sort. Oh, I should close the. So this is the insertion sort that we covered last time. So, and this is merge sort. So these three cells are algorithms that we covered, and this is bubble sort. So let's look at the performance on these different algorithms. So yeah, bubble is the slowest one because it's like two nested loops, for loops. So let's look at the other distribution of data. Few unique, it means that we have some repeated values. And you can see that quicksort was the faster one. So then merge sort, and then insertion sort.
What's shell sort?
I don't know. You can Google it. There are many modifications of these algorithms. Because it works. Yeah, the bubble sort is the slowest because it should go through all the elements and n. And so the time complexity n squared here in any case.
So the fastest one just depends on like the actual data that's in the list.
So yeah, the performance of algorithm depends on the data. So for example, this is like reverse sorted from greatest to the. Oh, sorry. Did you find what is this shell?
Oh, I'm looking it up right now.
Well, it should be a modification of some of the algorithms
Yeah.
that we covered.
Choosing the gaps. From the which elements are sorted.
Does it say that which algorithm like it uses as or similar to? Okay, so meanwhile we can look at the. Sorry, I will finish answering your question. So this is called average complexity. Average complexity means that we try different data, like sorted, random, like sorted in reverse order, and measure the time of average time of our algorithms. This is called average time complexity. So oh, by the way, for quicksort, the average time complexity is the same as for merge sort. Because if you think about splitting into 3 lists, and if, for example, your pivot element will be always in between, then the performance will be similar to the merge sort when we split just in 2 halves. Yep.
So it's a modification of insertion sort actually, where it basically does insertion sort takes it's very bad at going over like elements that are very far from each other and inserting them. It basically takes elements that are far from each other and sorts them efficiently and then gradually closes the gap until the list is sorted and the gap is equal to like zero. Like it just has an arbitrary gap. And it just compares the elements far from each other until the gap is like 0. And it's good at sorting lists that are already almost sorted.
Yeah, but and it works pretty fast. I mean, from these examples. So reverse order. You remember in reverse order, quicksort has the worst time complexity, but still it worked pretty fast. Yeah, we don't. I don't want to wait for bubble sort. Let's go to let's go to the next distribution.
What about the
So yes, there is sound. Actually, I don't know. Oh, this was just muted. So okay, so let's skip the bubble sort and go to the almost sorted. So insertion sort actually works. What is the time complexity for what is the best time complexity for insertion sort? Do you remember? No, it's all because still we should go through all the elements. but still it's the best that we can have for sorting. Well, actually, what is the first one? Actually, in this case, the first selection sort was worse than the bubble sort. So I wasn't quite correct when I said the bubble sort is the worst. So, okay, that's it's enough sounds. So, yeah, that's it for today, and let's take a quiz, which includes also the time complexity of the previous insertion sort. Oh, by the way, there is a mistaken quiz. So if when quiz asks you about the best time complexity for quick sort, the correct answer is n. We provide the example today when each element is the same. But for quiz, you should answer n log n. I believe we just noticed this error mistake today, so I don't think they fixed this. So you should answer and incorrectly, and incorrect answer will be counted as correct. So it's about the best case for quick sort. Oh, where is quiz? And I believe also in slides, let's see. Yeah. Oh, okay. No, in slides it's correct. Yeah, the quick sort, the best is all of them. But in quizzes, for some reason, it's n log n. Counted as correct. Let's go. Oh, actually, we will finish like half an hour earlier today. I think we should thank Aiden because he coded fast the quick sort.
Okay, listen, when you go in my room, there's no way. Okay, because you cannot speak about. No, but
The wrong one.
The wrong one is the quick sort best time complexity. So it will count correct as n log n, but it's not.
Okay, so what should we put in log n?
Yes, but the correct is n.
For a quick sort, the best case, mark. Correct. Wait. What was the error?
The error was quick sort. So so the best time complexity for quick sort
Log n.
is n, but in quiz you should answer n log n to get full mark. So is big O of n, but in quiz it's n log n. So answer incorrectly and you will get full mark. Oh, great.